friends, in this video we are going to study the architecture of ARM processor. Here we will study the various components, or we can say the block diagram of the ARM processor, and then we will see the function of each of the blocks present in the block diagram. Okay, so let's start with our topic. ARM processor, it is one of the family of the CPUs which is based on the RISC architecture. RISC means the reduced instruction set computer. So ARM processor, they are based on the RISC architecture, means they will also have the instructions, small instructions are present in it, and less number of instructions are present. So if we see the architecture of the ARM processor, okay, this ARM processor is used as a processor's embedded system. Okay, so we can say that it is the engine in a system. It acts as a engine in a system. So in an embedded system, the main part is the processor, and processor is the ARM processor. So this processor acts as an engine in a system. Because why it acts as an engine? Because it is responsible for fetching of the instructions, which is the work of every processor, because processor is used for processing the operations, for doing the mathematical calculations and all. Okay, and in a system we write the programs. Okay, and programs, they consist of the instructions. So what the processor do, the processors, they fetch the instructions and then execute them. So that is why the ARM processor is called the engine in a system, because it is also responsible for the fetching and executing of the instruction. Now if we talk about the size of the ARM processor, then their size is small. Okay, because less number of instructions are present in it, as they are based on the RISC architecture. So less number of instructions means less transistors are required in the chip, and less transistor means that the size of the IC is also very small. So size of the ARM processor is small, so that is why it also requires some other components, or we can say some additional components are being attached with this processor to perform some other functions. So the ARM processor, it also consists of some additional components with it. So if we see the basic structure of ARM processor, then it will consist of the ARM core plus some other additional components. So if we see the architecture as a whole, it will consist of the ARM core plus some additional components present in it. And the study of this architecture is very important, because the selection of the ARM processor is based on this architecture. Okay, now let's see the diagram or the basic structure of the ARM core. So this is the model which is called the ARM core data flow model. This model shows that how the data flows between the various components present in the ARM processor. So in this data flow model, you can see the various components and how these lines are showing that how the data is flowing between these components. Okay. So in this model, you can see that we are having the address register, incrementer, ALU, that is arithmetic logic unit, multiply, accumulate unit, MAC, then register file, instruction decoder, and sign extend. Now this instruction decoder, it is going to accept the data. Okay, then this data will be decoded, data will be given to this instruction decoder, also to this sign extend. Okay, then registers are going to read this data, and then the arithmetic and logical operations are performed in it. Then in the multiply and accumulate unit, because we know that in the ARM processor we are having the three operands. Okay, two are the source operands and one is the destination operand. So source operands and destination operands, they are being accumulated, result is being stored. Address register is going to generate the address, incrementer is going to increment the addresses. Okay, so this is how PC is the program counter. Program counter is providing the address that where the next instruction is being written. Result bus, it is carrying the result. Okay, here also we are having two buses, A bus and B bus, which is carrying the addresses of the two source operands. Okay, so this is how the data is flowing between the various components. Now let us study the function of these components one by one. First we will start with the data bus. Now as the name says, the data bus, it carries the data. So the data is going to enter the ARM core through the data. Now as the architecture of the ARM processor, it supports the von Neumann architecture. And in this type of architecture, same bus is being shared by the data and the instructions. Okay, so here we are having the data bus. So this data bus will not only carry the data but also the instructions in it. Okay, because processors, they support the von Neumann architecture. Now there are two buses called the A bus and the B bus. Okay, now the data which these buses is carry, it can be an instruction opcode. That what type of operation the instruction is going to perform, that is the opcode. Okay, so data can be the opcode, and this data can be carried by the two buses, A bus and the B bus. Okay, so here the data is being given to the instruction decoder, which is the instruction opcode. This opcode will be decoded by the instruction decoder, and here with the A bus and B bus, the data or the instructions, they can be transferred from one component to another. Next is the multiply and the accumulate unit. This is one unit, multiply and accumulate unit, and also we are having the arithmetic logic unit ALU. So as we know that in the ARM processor we are having the three operands. Okay, in every instruction we will have the three operands. So out of these three operands, as I have said that two operands are the source operands and one is the destination operand. So two operands or the two input, or we can say source operands, and are n. Okay, you can see here in the diagram also we are having rm and rn. Okay, these are the two operands. Now this ALU and the MAC units, these units they read these two operands. Okay, and according to the instruction that what operation you have to perform on these two operands, according to that result is generated, and this result is stored using the result bus. So the result of this operation is being stored using the buses A bus and the B bus, and the desired operation is being done. Now this result is to be stored at the destination, and for the destination we used another called the RD register. Okay, so you can see that these multiply and accumulate unit, you can see in the diagram that we are having the two operands Rn and Rm. These two operands are then the specified operation is being performed on, then according to that the result is being generated. This result is being carried by the result bus and stored in the destination register, that is RD. So this register file is carrying the general purpose registers R0 to R15. Out of them we are using these registers for storing the operands and the destination, the result. Okay, and these multiply, accumulate unit and arithmetic logic unit, it is performing the operations on these operand according to the instruction. Now next is the address register. This address register, it is responsible for storing the address which is generated by the multiply and the accumulate unit and the arithmetic logic unit. Okay, so it stores the address which is generated by these instructions and then load that, place that address on the address bus. Next block in the in this architecture is the incrementer. Now this incrementer is getting the input from the address register, so it is getting the address. Now this address is incremented and then it is supplied again to the address register, so that the address register can point towards the next address where the instruction is being written. So the work of incrementer is to upgrade the, okay, so that it can point to the next memory address. Now in the processor there are the exceptions or the interrupts. So in the case of exceptions and interrupts, there is a need to change the memory location. Okay, because whenever any interrupt is given to the processor, then it jumps to some other memory location and then execute the program which is written at that memory location. So in the case of exception and interrupts also, there is a need to change the address. So in that case also, this incrementer is helpful. It is going to change the contents of the address register according to that. Next is the barrel shifter. Now in the ARM processor, there is a specific component called barrel shifter which is responsible for the shift operations. In some processor, there are instructions directly for performing the shift operation, but in ARM processor, we are having this component barrel shifter. Now you can see in the diagram that the input to the barrel shifter is the RM operand. So the contents of the RM, they can be shifted. Okay. So barrel shifter is responsible for performing the shift operations in the ARM processor, and it shifts the contents of the register RM. Okay. After that, the next is the register file. In the ARM processor, there are 16 32-bit registers. From R0 to R15. Okay, you can see in the diagram also that we are having R0 to R15, 16 registers are there, and each of the register is a 32-bit register. It can store 32-bit of data, and these registers are usually used for storing the data. So for storage purpose, these registers are used. Next component is the sign extend. Now, in the processor, sometimes there are required that the operations are to be performed with the signed numbers. Okay, positive and negative numbers are there, and on those numbers, the operations are to be performed. So, sign extend. So in the operations where the signed numbers are required, so the ARM processor, it deals with the 32-bit of data. So whenever the processor, it reads an 8-bit or 32-bit of signed number from the memory, then what it does, it extends the number. How it extends? It converts the 8 and 16-bit number into a 32-bit value, and then place the 32-bit value into the registers value. Okay, registers, they can store 32-bit of data. So whenever an 8-bit or 16-bit signed number is being encountered by the processor, then processor converts that number into 32-bit value and then store that value into the registers. So you can see here data is present, data is of 8-bit or 16-bit signed number, that is extended and then stored into the register files. Okay. Next block is the instruction decoder. Now the function of instruction decoder is to decode the instructions, and then according to the operation which is to be performed by the instruction, then it will be executed. So main function of instruction decoder is to decode the instruction, read from the memory, and then the instruction is executed. Okay, so these are the various blocks present in the architecture or in the core of the ARM processors. Okay, we have seen the functions of every component. We have seen that it is having first the data bus. The data bus is there, then incrementer, address register, multiply accumulate unit, ALU, barrel shifter, register file, instruction decoder, and signed extend. Okay, we have seen that how the data is flowing between these components and the functions of these components. So I hope that this topic, architecture of ARM processor, is now clear to you. Thank you.